Okay, so Nikki and Nicole told me that the homework was really hard. So I thought I'd just make this real quick, just kind of go over them so that hopefully tonight, while you're working on them, if you're stuck, just watch this. And I hope that you try it all on your own first. Then go back and watch this. And if you're stuck, as soon as you get the next step, pause it, and then keep trying it. And don't just watch this and get all the answers. That won't help you. So I'm just going to go over all four of these real quick. And I forgot to film during class for Micah. I forgot we need to film for you every day. All we did today was we went over the test, went over the homework from the last videos, the three-parter from yesterday. Was that yesterday? I don't remember. No, whatever. Anyway, we just went over those, and then nobody was feeling the use substitution thing. So the homework, whoa, that's really close. I'm going to try to do this just holding it so it's nice and zoomed in on the writing. We'll see how this goes. As long as I don't cover the microphone again. So the homework was, gotta get orientated here, 7.2, 21 through 24. Okay, so now I'm going to go over these real quick. Hopefully it doesn't take long. 21. I wrote it it's given to you like this. Turns out I think this is probably the hardest one. And they tell you to use u equal to x over 3. Okay. Well, in all of these that we've done before, it was pretty obvious in the equation where u was. You could just take that, and there was like an x over 3 in here, and you just rewrote it. That doesn't happen on this one. So what we got to do is we're actually going to, it's similar to like what we usually do with the du piece or the dx piece. We'll take this and actually, I'm making people sick probably with all this camera shaking. Here, that'll be better. So we'll take this and actually solve for x. So if I just multiply by 3 on both sides, I get 3u equals x. So now I can substitute in 3u for x. And then need to get rid of the dx, so I could rewrite it first. So dx equal over 3u squared. I'm trying to look through the iPad and write. It's pretty hard. I can't do it that way. Okay, so I can put in my 3u for x. I need to get rid of the dx, so I need to do the derivative of this. So du will equal, that's just like 1/3 x, so 1/3 dx. Multiply both sides by 3, so 3 du equal to dx. So now I've changed it to 3 du over 3u squared, that's 9u squared plus 9. And you may be thinking, well, how does that help? And it does, though. It helps a lot. Because I can pull some stuff out of here and make it look like a derivative that I know the answer to. So the way I can do that, you might notice, well, this 3 du on top, let's get rid of that. This is, and you could have done this at the beginning. Remember, if you know your properties of integrals, you know that I could rewrite this as 3 times the integral of du over 9u squared plus 9. So I just brought that 3 out of the integral. And then this du over piece, I'm just going to change that to, whoops, I forgot the 3. 3 1 over 9u squared plus 9 du. Hopefully now you can recognize this. You could recognize that it's almost something that you know the antiderivative of. It's real close. You could change that bottom. You could maybe factor something out, and then boom, you'll have it. I just realized I was covering the microphone. Hopefully you can still hear me, because I'm not starting over. So we get to that. I was saying, hopefully now you can see that it's really, really close to something that I know the antiderivative of. You could get rid of something on the bottom there, and then it will be. But if you can't think of it, if I factor a 9 out of that, I will have 3 integral 1 over, factor a 9 out, so that's u squared plus 1 du. And now let's go ahead and get that 9 out of there, or pull a 1/9 out. So if I pull that outside, now I'll have out front, I'll have 3 times 1/9, and inside the integral I'll have 1 over u squared plus 1. That should look familiar. So on the outside, 3 times 1/9 is just 1/3. Integral 1 over u squared plus 1 du. Hopefully that's all you need, and you can take it from there. I mean, 1 over u squared plus 1, isn't that just the inverse tangent of u? So I'd have 1/3 inverse tangent of u plus c. Right, because the derivative of that is that. Just leave the 1/3 sitting out there out front. Plug u back in. So the answer is 1/3 inverse tangent of x over 3 plus c. Like I said, I think that was about the hardest one, just because of the weirdness up here. Here's 22. Okay, so in this one they give you that, and this one's more of the normal style where they're like u equals 1 minus r to the 3rd. Okay, so that makes it easier. So now we just have the integral of 9r squared dr over the square root of u. Well, okay, we need du now, so du equals, derivative of that would just be bring down the 3, negative 3r squared dr. Again, it's easiest to solve for dr, so divide by this, so I'll have dr equals negative 1 over 3r squared times du. Oops. Trying better ways to study this thing. Once I got that, I could plug in all of that for dr. So my hand gets in the way now. Dang it, there's just no easy way to do this. So now I'll have, let's see, 9r squared times negative 1 over 3r squared du all over square root of u. Also this multiplication here, it's going to be, r squareds are going to cancel, 9 over 3 is 3, there's a negative, so we'll have negative 3 over the square root of u du. Which, for me, it's easier to write that as negative 3, I just thought of another way too, u to the negative 1/2 well, okay, so now antiderivative of that, or do the integral. See, if that's u to the negative 1/2, that would be u to the positive 1/2 is what it used to be before I do the derivative. So 1/2 times what gives me 3, that would be 6. It needs to be negative plus c, and then put u back in. So it's negative 6 times 1 minus r to the third to the 1/2 plus c. All right, u comes back in. That's it. And the next one. The last two are very similar. Well, maybe not. The answers are similar. Well, yeah, they are. 23, let's see here. This one looks intimidating when you first write it, but it's really not bad. So that's what we're given. U equals 1 minus cosine t over 2. Oh, that's easy, so that's just that. So I can change this to u squared times the sine of t over 2 dt. Well, I need to get rid of this, so going over here, du is derivative of that. Well, derivative of 1, that's just going to go away. Derivative of cosine is negative sine, but it's already negative, so it's going to be the positive sine of t over 2. But I got to chain rule it, so derivative of t over 2. Derivative of t over 2 is 1/2, so I got to put that out front. I'm not talking to myself, I promise. Making a video.
Take a second look, and that's how you're holding something like that. You must be talking into that.
Yeah. So there's du. Now we'll solve. Oops, forgot the dt. So solving for dt, multiply both sides by 2. So I'll have 2 du over the sine of t over 2 equals dt. Plugging that in for dt, I can see that if I multiply this by this, the sines of t over 2's are going to go away, so it'll just be 2 du. So really, it's just 2u squared du. I'll just leave it at that. You could take it from there. And the final answer, you should get 2/3 1 minus cosine of t over 2 third plus c. And the last one. Oops. Again, plug in u there, so I'll have 8u squared times y to the third plus 2y dy. Need to get rid of these, so do the derivative of this over here, so I'll have du equals 4y to the third plus 8y dy. Well, that's convenient. So now dy equals, if I divide both sides with that, 1 over 4y to the third plus 8y du. You might already see what's going to happen here. If not, plug that in for dy, so I'll have 8u squared times y to the third plus 2y times dy, which is this, 1 over, what is it? 4y to the third plus 8y du. Well, if I multiply these together, hopefully you can recognize that something special is going to happen here. I'll have y to the third plus 2y over, I could factor a 4 out of that. So 4 times y to the third plus 2y. And then this out front. I'm almost done. And du. So I can drop those. So I have 8u squared over 4, which is just 2u squared du. Told you these were similar. So you have that. Again, I'll let you finish the rest. And your final answer should be 2/3 times y to the fourth plus 4y squared plus 1 to the third plus c. So hopefully this is getting a little bit easier. It will never be easy, but hopefully a little bit easier. And yeah, that's it.